8687 Vanagon. Customer complains about high fuel consumption, smokes pretty bad out the exhaust, or pig ridge I should say. And when running the engine, when driving window down, you can smell the richness. So first thing I always check is the exhaust, it's the O2 sensor first to make sure that it's connected, which it was. So then all I did was disconnect it, and you can see somebody's been in here before and they put a crimp connector on here. So with the key on, what you want to read here is 0.45 volts. And as you can see, it says 0 volts. So this O2 sensor wire, which is supposed to have a reference or a bias voltage of 0.45 or half a volt, it's shielded with a shield wire or a shunt. So I think somebody crimped the shunt around the reference signal wire, the bias voltage, and that obviously pulls that bias to ground. And when it pulls that 0.45 to ground, the computer thinks that the engine's running lean, so it adds fuel like crazy, trying to get a rich signal from the O2. If this were reading 0.45, then I would check it with the O2 sensor connected, because then I would be suspect that the O2 sensor stuck lean, causing the rich running condition. But anyways, I'm going to remove this connector carefully and see if those two wires are crimped together. Okay, so all I did was remove the plastic, and you can see that it looks like the shunt is touching the signal. So I'm just going to pry that apart and we'll continue. Okay, so all I did was spread the legs a little bit. That's what she sent. It's hard to tell here, sorry, camera's not focusing, but you can see the wire. There should be two distinct sets of wires here, and to me it looks like they're just wrapped together. So I'm going to separate them. Actually, you can see the inner core here. Come on. So you can see there's a outer green sleeve and there's an inner green sleeve, and those should be two distinct separate items. So let me just clean that off for you and then you'll see what I mean. Sorry, the reason I'm not using my glasses is because this is better quality video, hopefully, as long as the video is in focus. So all I did was I took the I cut the wire, and then I stripped off the outer green layer. Then I took the shield wire and I just bent it back, so that you can basically trim that shield wire now. And then up here I'm going to peel back the insulation here and then crimp a spade connector on there. So I'll get you that shot next. Okay, so you can see here there's the two distinct wires. There's the shield or the shunt. Here's the reference. Voltmeter is still attached to ground. Take my green positive lead and I should get 0.45 when this is attached. So that's attached. Come on, wiggle, wiggle. There we go. Sorry, the ground here moved on me. So as you can see, I got 0.45 now. So the next step now would be to connect the O2 sensor and to make sure that it is cycling, or that the O2 doesn't cycle. The engine computer makes the O2 cycle. So I'll get you that in the next shot. Okay, so I put a little coupling in here. It's a golden colored one, just so that I could so that I could clamp the metal part of the connector. If I didn't put the coupling in, this red connector would be flush with this black plastic, and I wouldn't be able to get good contact. So anyways, that's connected, and you can see at idle the O2 is already switching. It's rich right now. Computer's going to force lean. There's the lean. Now it goes back rich, back down to lean, and back up to rich. The warmer the O2, the quicker the signal, or the quicker it's able to switch. We can just rev up the engine a bit and you'll see it switching quicker. If it sticks too high for too long, there's other things going on. So again, this is the first thing that I did. There may very well be more work involved, but you can see now there's 2 humps per every 2 seconds. It'll probably increase also when obviously I increase RPM, and it'll get to the point where there's at least 3-4 humps in this screen here. And like I said, the quicker the O2 can cycle, the better the ECM can adjust fuel mixture. The exhaust already smells way better, not rich anymore. So again, this was the main concern, or the main reason for the running rich. It might be a good idea to check distributor caps, spark plugs as well, because they're probably all black, but as you can see it's running, and they'll clean off themselves now that the air fuel mixture is good. Or that now that the engine computer can control it. You might want to still check fuel pressure. Sometimes these pressure regulators stick, and then you got rich running condition, but if that were the case, then it would be stuck rich right now as well. So the fact that it's able to go rich lean tells me it's fairly good in operation right now. For some reason this guy is disconnected. That's supposed to be down here. That's the evap purge. It gets triggered by this line here. Once the throttle body opens up, it's ported vacuum that supplies vacuum to this, and then, supplies vacuum to the pod that's back there. Once the pod is open, the manifold sucks in evap emissions, hydrocarbons from the charcoal canister. Lots of info. If you have any questions, let me know. I keep hitting my head on these things. So as you can see, the evap purge goes underneath the airflow meter, and it connects right here. So obviously this airflow meter is new, plus there's a Vanagon syndrome wiring harness, I guess. But in all likelihood, this was the main problem, and probably didn't need an airflow meter. Anyways, time to take it for a test drive. Everything else is looking pretty good.